Adding baking soda to vinegar causes bubbling and foaming. This is a reaction between an acid and a base. But what makes an acid and base strong or weak? Let's take a look. According to the Brinsted-Lowry definitions, acids and bases are characterized by the exchange of hydrogen ions. Acids are molecules that donate one hydrogen ion in a solution, while bases take one hydrogen ion. Strong acids and bases ionize fully in an aqueous solution. Weak acids and bases also ionize, but only partially, and the reaction is reversible. So how do we know if an acid or base is strong or weak? A simple way to determine strength is to add the acid or base to water. High reactivity means a stronger acid or base. This reactivity is measured with a value called the Ka or Kb value. It tells us how reactive an acid or a base is based on how many hydronium or hydroxide ions are formed during the reaction. Another way you can tell an acid or base's strength is bond energy. For acids, when the bond energy is small, the acid molecule's bond is easy to break and the hydrogen ion takes less energy to dissociate. Hence, a strong acid will have a low bond energy. Similarly, a basic molecule with a strong bond between the hydroxide ion and the positive ion will be a weak base, while a strong base will have a low bond energy. Electronegativity can also determine the strength of an acid or base. Electronegativity is a measure of how well an atom or molecule shares an electron. When a molecule has a high electronegativity, it is a strong acid. Strong bases, however, have lower electronegativity. Another way to determine strength is to measure the stability of the acid's conjugate base, which is the part of the molecule that is left after dissociation. A more stable conjugate base means the acid will be stronger. The molecule is more stable without the hydrogen ion and thus more likely to release it. Now that we've covered properties that make strong acids and bases, let's look at some common examples you're probably familiar with. Battery acid is a strong acid. It reacts strongly by eating away at materials that it touches. This is one of the reasons why we do not cut open batteries. If we did, we would get battery acid on our hands. The acid would begin reacting and our skin would start dissolving. Bleach and lye are examples of strong bases. They can also damage our skin, which is why water is added to bleach or lye before using them to clean. We are surrounded by examples of weak acids and weak bases. At the breakfast table, coffee and orange juice are examples of weak acids. Also in the kitchen is an example of a weak base, baking soda. We can add baking soda to a weak acid, white vinegar, to see a bubbly reaction. We hope you feel prepped and empowered by this review of acids and bases. Thanks for watching.